Hello, everyone. Our final project is about the recent surge of health concerns arising around climate change, specifically about particulate 2.5 pollutants. We'll be placing emphasis on the effects experienced by participants below the poverty level in California, drawing inspiration from historical cases found in Italy and recently found similar correlations in 2020. The data we'd be using would be provided by the CDC, the places dataset containing entries for the individuals in California for asthma. And we'd also have a second data set so we can match the actual air quality results found to their appropriate location in California. Here's the code. And we have some irregular values that are present that we could filter later in data cleaning, brought to you by Heidi.
Now we are going to talk about how we clean the data. After loading in the Places County health data, we filtered for results only in California with the measure ID of C asthma, current asthma. We also saw that a lot of information repeats, such as state ABBR and state descending. Some columns only have one value or even zero values. To avoid redundant information and columns that only consisted of NANs, we dropped these columns. Lastly, we had to ensure that each county represents one row or observation in our data. So we created a pivot table and merged it with select columns from the original data frame, California Places. We cleaned our PM2.5 pollution data by dropping irrelevant columns and verify whether NAN values exist using .is_NA. A clean dataset doesn't have NAN values, so we replace these with unknown. Now, both of our datasets are clean and ready for data exploration.
As Heidi mentioned, now we can use our clean data to explore the relationship between PM2.5 concentration and asthma prevalence. So using chloroplast maps, we can look at the PM2.5 concentration throughout California counties in 2022. It looks like during the summer, overall throughout California, there's less PM2.5 concentration, while in the spring, there's a spike in Southern California, and then for the rest of the months, Central California generally had a higher concentration. Now looking at the comparison map between asthma prevalence and PM2.5 levels, we see that there is that consistency between both of those with Central California, but inconsistency with Northern California and Central California. Now passing it off to Katelyn for a deeper dive into regional analysis.
Thank you, Kate. Next, we'll explore asthma prevalence in California using the Places dataset, focusing on regional and county-level trends like our previous analyses on the pollutant data. This will allow us to explore how asthma rates vary geographically and how these trends might relate to our confounding factors like socioeconomic demographics. Starting off with our box plots, Northern California shows a nearly normal distribution of asthma prevalence in the highest median. Central California remains fairly symmetric, and Southern California remains clearly left skewed with no outliers. From this, we would anticipate Northern California to the greatest concentrations of PM2.5 and Southern California to be the lowest. And while the latter holds true, the former is not reflected in our previous analyses. Moving on to the top 10 counties for asthma prevalence, we see that Northern California dominates this list with 8 out of 10 counties. Southern California has no counties listed, as expected, aligning with our hypotheses. And now, Kyla will wrap it up with our ethical considerations and final conclusion. Thank you.
Thanks, Caitlin. Our analysis places a strong emphasis on ethics and privacy. The data collected with informed consent and anonymized ensures confidentiality, but may face biases from self-reporting and limited diversity due to its focus on individuals below 150% of the poverty line. To address this, we reviewed for imbalances, applied statistical adjustments, and upheld strict privacy safeguards. For the key takeaways for this study, we examined the relationship between PM2.5 pollution and asthma prevalence in California. We found that counties in Central and Northern California, where pollution levels are higher, also have higher asthma rates compared to Southern California. However, limitations such as potential oversimplification of urban and rural air quality variations and the lack of temporal trends, and also exclusion of key factors like socioeconomic status, suggest that future research should incorporate multi-year datasets and additional variables for a more comprehensive analysis. Overall, our findings underscore the societal impact of PM2.5 pollution, particularly in low-income communities, highlighting the urgent need for targeted environmental and public health interventions. Thank you.